At the Onshape event last week, it was reiterated that Onshape could manage changes to individual features, allowing many people to modify the same model at the same time. Is that a big deal? Let's talk about that next. Okay, let's talk a little bit of context here. So when Onshape was first launched, it was basically one of the very first CAD solutions that could be used in a browser, okay? Completely web native, completely cloud native. One of the implications there is that you could take the URL, send it to someone else, and they could jump into the same model. The natural follow-on is, well, can I have two people modifying the same model at the same time? And the answer is yes. And it's a pretty fascinating capability. You can debate whether or not it's a real use case, but there are other use cases where that capability is really powerful and really capable. But there are other implications for these other use cases that are really pretty crucial. And for some more context, we actually need to look at how software configuration management tools manage changes to code. In software configuration management tools, you can take one piece of code and branch it. As a matter of fact, you can create multiple branches. Then individuals can modify those branches of code separately. And that's illustrated here with the yellow lines. Now, of course, when those people are done with their changes, you want to be able to merge it back together. So what the key enabler here is that a tool like GitHub, other software configuration management tools, they can track the changes at a very granular level. They know what aspects of the code were modified in which branch, and if there are no conflicts, then you can bring them back together. And you have one set of code again, you merge those changes together, and you have one set of code again that you take forward as one branch. And then you could branch it again if you wanted to and go from there. So this is our simultaneous user modifying the same code at the same time use case in the software world. This is how they manage it. But the key enabler here is being able to track changes in a very granular fashion. It's not for the whole set of code, it's for a snippet of the code, right? It can understand what's been changed and what hasn't been changed. And that allows you to merge the code back together. And it allows it to identify when there are conflicts between change. That's the big key in merging things back together. If there's no conflict, it should be easy. But if there are conflicts, give them a way to resolve it. But in this case, with GitHub and software configuration management tools, this capability has been in place for a while. So, what are the implications for mechanical design and Onshape? Well, this scenario looks almost exactly the same. Let's say we have one part, we branch it, we have two different users modifying it simultaneously, and then you want to be able to bring it back together. Well, because Onshape understands, tracks, and manages those changes at a feature level, not at the model level, at a feature level, it understands where there might be conflicts. It understands what to compare to one another. And if there are no conflicts, then you can merge it back together into a single component. Okay, so who cares? Why does this capability matter? Well, when you look at what it can enable, the use cases are pretty relevant. When you look at additive manufacturing and 3D printing, there's a lot of part consolidation nowadays. And that's good from a sourcing and supply chain perspective. That's good stuff. But what it means is that you might have different people that need to work on different aspects of the model at the same time. You don't want one person to be logged out and not be able to make changes while another person is sitting on their hands. So in this case, they can work on separate branches. They can merge it back together when the time is right. Another really interesting use case is with change management. So with this, you might have many change requests you're trying to address at one time. And as you explore different options that can address all those change orders, you can create branches for each one of those, all those options, right? And you might have a brilliant one as the third branch and another brilliant option with the fifth branch, and they don't conflict with one another. You can merge all those back into the same model. So what's interesting about this, it's not just work in process design where you have a bunch of engineers that want to work on the same thing at the same time. That's one use case. Maybe it's applicable, maybe it's not. But there are business cases, business processes, where this capability becomes a pretty key enabler, both from mainly from a productivity perspective. You don't want someone sitting and waiting around while one person is locking the model. So as you look at your business processes, as you kind of consider those things, look at how branching and merging can help you and how it can enable many people to do something at the same time. That's the powerful aspect of this capability. That's it. Take care. Talk soon.